Welcome to another HVAC-Engineering-Techie channel training video. Today's video is on the technical retrocommissioning process. That's the process of the cheapest possible way to fix an existing building. It's a process I really like doing, and I'm excited to share this process with you. Don't forget, HVAC Engineering-Techie channel is a channel that brings you all things HVAC, engineering design, construction, equipment, systems, test and balance, controls, and energy performance. Before we start this video, I'd like to ask you a favor. If you're not already a subscribing member, I'd really appreciate if you become one. It's really easy to do. It costs you absolutely nothing. No one will ever bug you. Just hit that button down below that says subscribe. Give me a thumbs up if you like the video. And the reason for that is Google uses that to evaluate my videos, which keeps me on the line. I really appreciate it. Let's get started on retrocommissioning. Thanks. So first we're going to go through the different videos available for retrocommissioning so you'll know what's in this one and what's coming for the others. So the first is C20, which is the technical retrocommissioning process, which is just kind of an overview of what we do and why it's done that way. So that's today's video. Cx-20 is the RCx overview and process matrix. It goes through a process matrix that shows you in order what's done. C22 is RCx contracts and pre-project planning. Cx-23 is RCx pre-site activities. Cx-24 is RCx system assessment and issue discovery. RCx is all about finding what's wrong with the building, the real root cause. Cx-25 is RCx system testing. Cx-26 is RCx root cause identification and issue analysis. This is really, really important. What happens if you don't do that? You start trying to fix symptoms, which never fixes the real problem. Cx-27 is RX quick fixes, RCx quick fixes, and system optimization, another really important part. Cx-28, RCx corrective actions and post-project activities. So these are the videos that make up RCx, and I think you'll find them really, really beneficial. All right, so retrocommissioning, what is it? Retrocommissioning is how to fix an underperforming building. Now, I'm going to have some definitions a little bit that'll try to help the confusion between commissioning, existing building commissioning, retrocommissioning, recommissioning, all these different words, and what the industry actually is trying to tell you. So first, it's to fix an unfixable building. You know, most people don't realize how terrible operating condition our buildings are in. I have never entered a building, an existing building, that's working correctly. They've always got some issue, and a lot of times they're really large issues. And so what happens is people that operate buildings get so frustrated, they'll say, well, this must be a controls issue, so they call a control company, and they come out and say everything's working fine. But it's not. The building's not comfortable. People are having problems. They're not happy. We need to fix this. Well, I don't know what to tell you. And they get that a lot because or they'll say, oh, it's a test and balance problem. And the test and balance guy comes out and says, that looks fine to me. And the reason is because we have almost no people left anymore who understand all systems in a building and look at it from a holistic point of view. And that's what this retrocommissioning is all about, is a process that lets you discover what's really wrong with the building. So buildings are unfixable. Improve indoor environmental quality and comfort, which means, indoor air quality is comfort, HVAC comfort, it's temperature, it's humidity, it's lighting levels, so the lighting level, or it's glare. We have glare, it's sound and vibration. And it's IAQ, issues like that. So there's a bunch of issues that make it a good building. Reduce consumption of electricity, water, and gas. No one wants to pay more than they should be. And so retrocommissioning is a way to do that. Improve the value of the asset. Once you have a building that's working, you have happy tenants, you can actually charge them a little more. And your building value goes up, so it's good. Improve building risk management. You have less unhappy customers or actually a real problem in the building, so you don't want to get people sick. And retrocommissioning is actually the lowest cost method for improving building performance. One way you can do it, you can just rip all the systems out, put all brand new systems in, recommission it. Of course, you can't do that with people in buildings, so you have to. There's no one actually does that, but you can do that. But it's much better to go fix what you got. So retrocommission is by far the lowest cost way to do that. It improves building temperature and humidity problems, improves utility cost reduction strategies, improves occupant comfort and productivity, improves facility systems maintenance. It's now much easier to maintain, and maybe your operators, maintenance people have some better tricks now what to do. RCx program costs are flexible as determined by the owner. So in other words, we can fix everything, which costs a little bit more, or we can fix less, but still, well, what we do is expose to the owner, here's what needs to be done, here's how much it costs, here's the payback. And we do that with those things that need to be fixed, and he can make the decision what he wants to spend his money on, what's most important to him or them. Okay, what retrocommissioning is not, and this is kind of a little shot across the bow of some of our friends who basically use the processes from other groups. So like ASHRAE. ASHRAE has all these groups, but what happens is a lot of people believe retrocommissioning is just an energy audit. And it absolutely is not. It does include an energy audit, but it is not just an energy audit. Because what happens in an energy audit, you don't actually change anything, you don't fix anything. You just tell them you do all this stuff and you'll save some energy. And normally when this is done, because it's done with a very small budget, is this doesn't ever find root causes. And that's kind of a problem, because someone will tell you need to do something, you do it, it doesn't actually make a difference because it's not the real root cause. RCx is not an energy study. A lot of engineering companies say, well, come in and do an energy study, and we get it that way. It has a lot of energy study in it, our RCx, but it's not just an energy study. And it's not just TAB. Sure, we deal with TAB, we try to fix the deficiencies in TAB, but it's not just a TAB project. It's not just system troubleshooting. Well, of course, it includes system troubleshooting, but it's not just troubleshooting. And it's not just control system data analytics. I mean, a lot of people will come in and say, if you spend money and put this data analytics system in your building, which can be a really good thing, is going to solve all your problems. Well, it won't, because it's only dealing with one piece of the building. There's lots of other things that affect the building, and that's what this holistic approach is all about. RCx is not just standard building commissioning. A lot of people, especially in ASHRAE, say retrocommissioning is just applying the standard commissioning processes to an existing building, and that's absolutely not true. If you do that, you will miss the opportunity, something big time. Retrocommission is a real special process, and I am really excited to be a part of it, of developing that process, and it's a lot of fun. I tell you, the most fun I've ever had in business for all these years is doing retrocommissioning. If I could do nothing else but retrocommissioning, I'd be a happy camper. RCx is a separate commissioning process designed to fix poorly performing buildings. The separate process is really important. So here's the definitions. Now, these may not be everybody's definition, but the definitions that I've come across, having worked in ASHRAE, I've worked in NEB, having worked in different areas in engineering and contracting, and all these different businesses I've had, we've developed these over the years. Commissioning. Process of verifying and documenting that the facility and all its systems are planned, designed, installed, tested, operated, and are capable of being maintained to meet the owner's project requirements. And that's pretty much it. Whatever the OPR says, if you can deliver the OPR, you've done a great job in a new building. Recommissioning. Commissioning of a facility that was originally commissioned after construction to bring it back into its original operating parameters. So, over time, everything degrades. And recommissioning is basically coming back in and just going through everything and testing and setting it all back up so it's like it was when it's new. Well, the problem why that's not retrocommissioning is we're trying to take an existing building and we have no idea what they've done in that building until we get in. And most buildings are not static. They make a lot of changes. They move people around, they move walls around, they move zones around. They bring in different heat sources. They do all this stuff that changes the original design. So if you just bring it back to the original design, you're not going to solve all the problems. Ongoing commissioning. Utilize a monitoring-based performance system for feedback on performance to a continuous commissioning process can be performed corrections. This is a great process, but it's not retrocommissioning. Before you do ongoing commissioning, you need to retrocommission the building first to make sure it's working as best it can, and then go on. And because what this is about keeping persistence in the building. to keep it as working as well as it was. And it will even help you make it work better, but it's not retrocommissioning. Retrocommissioning, RCx, a special building commissioning and testing process applied to an existing facility for system functionality and comfort improvement. Improve systems operation, energy and water use reduction. So that's my definition. It might not be other people's, but retrocommissioning and recommissioning are definitely not the same time. And existing building commissioning, which is ASHRAE has a standard for this, commissioning an existing facility system for performance and to bring it back to the original design operating values. Again, they're trying to use new building commissioning processes on an existing building. And if you're just trying to bring it back to its original design values, this will actually work. But that's not what we're doing in retrocommissioning. If you do that, you will not fix the building. The main focus of technical RCx is to make existing systems perform as well as possible without large cost of replacing major systems. To this end, each system is to be optimized to allow the existing system to perform better than before the RCx project was performed and to meet desired project outcomes. And this is the major difference with retrocommissioning and regular commissioning, is when we go into the building, our expectations and the owner's expectations, because he's paying you some money, is he wants, when you leave, that the building is working better than when you got there. And if all you do is an energy audit or some other kind of just test, that won't happen. You'll come in and spend money, do stuff, but when you leave, it's still the same building. Nothing's changed. Retrocommissioning is designed to fix everything that can be fixed with a very small amount of money to make it work better. And it does work. But it's a process. It's not a linear process, unfortunately, and we'll be talking about that a lot during these sessions. But it's a process that's been developed by several different people. And what you do is you go through and you do these processes. And when you have a lot of these processes done, the issues just sort of rise up out of the pile, and you can actually see the real issues. It's really quite eye-opening once you figure that out. And it's been a real joy to be a part of that process and to fix a lot of buildings. So what does RCx involve? It involves system design reviews. In other words, you go back and find the original drawings, and you figure out, is this a really good design, or did this design have issues to start with? Most times, this is a joke kind of thing, but I actually found it to be very true as a designer, is as a designer, when you show something on a drawing and you show it perfectly, that's exactly how you want it done, and that's the right way to do it, you have a 50-50 chance of getting that design actually working in the field. If you show it wrong, I guarantee you they'll build it exactly like you show it. So the problem is there's a lot of design issues on existing buildings. And unfortunately, it's kind of embarrassing for me having been a designer, but we find about 20 to 30% of all the problems in a building are due to original design. And that's unfortunate, but that's what we find. Basic level 1 energy and water use audits. That's included in a retrocommission project, but it's much, much more than that. It's only level 1. Now, we'll explain this later in the other videos, but level 1 is basically just figuring out how much energy you're using and is it good or bad. It doesn't tell you a whole bunch of details after that. And we need to do energy and water. And there's really, we have a lot of guidelines from ASHRAE on exactly how to do an energy audit. Not many on how to do water audit, but we'll go through that. And you can use the same criteria they have at ASHRAE for energy, just apply it to water. Occupant, operator, and management interviews. And this is one of those processes that we explain for you how to do that. It may not make a lot of sense to you at the time, and some of the answers you get are strange, but later on they might become very, very important to your analysis process. System assessment and inspections. This is a standard process. This is a prescriptive process. You inspect all the systems and the equipment for any issues that are going to cause issues. Issue investigation and troubleshooting. A lot of times you find something and you have to go in and troubleshoot, trying to figure out what caused this or what's going on. This is why it's not a linear process. I lay this out in these videos as a linear thing, but it's not. Many times you get down here, you've gone through and inspect everything, you find a bunch of issues, and you realize you got to go back and do another interview because you got to figure out something, or you go back and do another test or something. So it's linear. So it may loop around a couple of times until you actually get done. Maintenance reviews and corrections. We need to review how maintenance is being done in the facility, and we might have to give some recommendations to the owner staff on how to actually do it better. I mean, there's many times I've been in a building where the operators actually don't know how to operate the system. The system's fairly complex, and and what happens is, when you build a brand new building, you bring in the operators and you train them. But 5 years from now, those people are probably not even there anymore. That's the biggest problem. Is that people come and go, and the people that understand what's going on may not be there anymore, and that sometimes that information does not get downloaded to the new employees. So we'll actually do a lot of training and retrocommissioning of tell them exactly how this is supposed to work and go show them this is how it works. And a lot of them, they go, wow, that's interesting. We didn't know that. We do quick fixes and adjustments, and this is the one thing that sets retrocommissioning apart, and that we will actually go in and fix things that are wrong. We don't have to go and say, well, this is a big list of things that need to be corrected. We'll do quick fixes and adjustments to the system because we're optimizing it as we go. And another reason is we don't want to cover up quick fixes. If you don't fix something that's obviously wrong, it could cover up something deeper that you won't be able to find because you'll be looking at this area that's got a quick fix. You cover it up, you get that corrected. Now you can tell what's going on underneath. System testing, you're going to test the systems. You're going to identify root causes of found issues. Like I said, this is really, really important. And this is the sleuthing part of retrocommissioning. People ask me, what does it take to be a successful retrocommissioning? And I've always said, a curious person. You need to be curious. You find something and say, what in the world causes that? What's going on? I don't understand. I found a lot of those. And you'd sit there and noodle on it until you actually figure out what's going on. So that's what makes it fun, actually. System test and balance. You really have, if you're not a test and balance person, you need to have someone on your team who is, because you're going to do that. I guarantee you there's a lot of test and balance issues. Test and balance is one of those things that doesn't stay static. If you move on air side, if you move something somewhere, it affects something elsewhere. And if you get 5 or 6 years of that, it's totally out of balance. So we'll need to not rebalance everything, but we will fix what's not working. Control system sequence and control corrections. Here's another deal. If you're not a control guy and you don't understand sequences and you can't do sequences, someone on your team needs to be, because this is the second area of I guarantee you, this will be problems. You'll have problems in here. Not because the original program may be not any good. It might not be good, but if it is good, it still has a lot of people working on it over the years, and it may have been changed to incorrect parameters, or it may actually, that sequence may have been blown out altogether. So you have to have a control person on it. System optimization adjustments. This is a process that's a little bit different, and we'll go through that. And then operator training. We do that as we're going. Or we may sit down and have a small classroom training session if it's a big deal, and identify possible capital corrections. So then once we get through the quick fixes, we're through the process, we will send a report to the owner with a list of the major capital items that need to be done to bring the building up to the best it can be. And that's the process. Now, those may or may not be done because it's up to the owner where they want to spend that money. And then, of course, the RCx report, which includes that. Technical RCx standard. This video uses the ANSI NEB RCx standard S120-2016. And actually, there's a newer version, 2019, which only changed some spelling errors or whatever, as the basis of the RCx technical process. Now, this is a technical process. It's a proven technical process of delivering building system performance and functionality. The technical process based upon experience of hundreds of RCx projects completed by the S120 Standard Development Committee members. We had, I think we had 20 people on this committee, if I remember right. And some of them were users, some of them were government people, some of them were providers like us. So we got to hear from people. So it's not just a standard for a provider like me. It basically was a standard to really for the industry. And we used the ANSI process, what made it open. So it's not a standard. NEB was in the process, but it is not actually just a NEB standard. It is a retrocommissioning standard, ANSI approved. So it's that's been good. It's this is what the 2016 looks like. 2019 looks a little different, but the information is very similar. So one thing a lot of customers ask us, well, does it really work? I mean, you're asking me to trust you, and unfortunately we are asking you to trust me. Well, there's been a few studies. LEED did a few studies, but they're not too good, and the reason is because they're focusing only on a LEED process building, which is somewhat limited for retrocommissioning. So there was a study that I found, this has been a few years ago. This was an energy performance technology concurrently for retroactive and ongoing commissioning. This is by Stephen Driver, and this was his PhD thesis. So he got his doctorate by studying a group of buildings. And then he gave an example of what was wrong. And it's the only study we've ever seen that has the detailed results of what they actually found. Now, I guarantee you that they would have found a lot more if they'd have used our retrocommissioning process. Because they probably didn't. They probably just used a standard process of audit and checking on things and just looking. And that, unfortunately, that's okay. That works, but you don't find everything because you don't have a holistic process that looks at everything. It just looks at, you find an issue, you try to follow that issue, and that's okay again, but it's not complete enough. And this was done in 2009, so it's a little old. There are 80 buildings surveyed. That surveyed is the key. Failure issues identified and savings calculated. Now, they found a lot of issues, but they did it from more of an energy audit standard than they did from actually fixing the building. Most common flaws, envelope leaks, building pressurization, 409, observation, incorrect installation, damage, drainage, missing equipment, 543. Remember, this is 80 buildings. Accessible issues, housekeeping, which is maintenance, engineering issues, over or undersize, 109, sequence optimization, tuning, programming, 336. Runtime, override, end-hand position, 51. Incorrect labeling, documentation, conflict, 87. Now that sounds like, why would that be in there? That could be a problem. If the operators can't deal with it because the wires aren't labeled, they don't know where they're going, or other things are labeled, like breaker panels are labeled wrong, they spend hours and hours and hours fooling with that. So that's actually a problem. Field BMS issues, incorrect wiring. Well, yeah, they didn't say anything about sequences, which they should have. Lawrence Livermore facility says the average savings is about 20% plus. Department of Energy said 20% plus. Industry average is 10 to 15%. Facilities with failed systems may have immediate payback. We've done some other studies. We tried to use it. We just couldn't use to a customer because they were way too good. I mean, when you find a building that's heating and cooling simultaneously, it can pay back in a week or 2 weeks. And you don't want to use that to try to market retrocommissioning service because it's an outlier, but it is possible. Now, it is also possible to have a building that's failed in the off position, and the owner's been putting up with it. Now, the problem is if you fix it and turn it on, the energy is actually going to go up a little. It doesn't happen very often, and normally it's just a little bitty piece, so it gets covered up, but it is possible. And the trouble is here is most facilities are never set up for proper operation, and few are ever optimized. So, many times when I'm doing retrocommissioning, I always have this little fear in the back of my neck. Man, I wonder if I'm going to be able to find anything in this building. And I got to tell you, that's not a problem. It has never been a problem. From the first day, it's never been a problem. So you don't need to feel bad about that. I guarantee you the building you're entering will have a problem. Who are the users of our RCx programs? Well, building owners. This doesn't work for anybody else. It's got to be an owner because what we're doing is for his benefit. Facility managers and operation managers, they can use the services also because they benefit because it makes their job easier. Federal and municipal building managers, college and university facility managers, manufacturing facilities owners and managers, hospital and medical facilities owners and managers, anyone who is responsible for a facility's profit, utility usage cost, and carbon footprint. Any of these systems should be interested in retrocommissioning process. Facility owners and managers who are responsible for keeping tenants happy. Now, a lot of my friends and associates in ASHRAE sell this service as energy only. And there's a lot of buyers that think that retrocommissioning is just to save energy. U.S. government is one of them. GSA, Pentagon issued several years ago an order that facilities have to improve their energy. I think it was 10% a year over so many years. And to do that, but they did let them said you can meet that goal by doing a retrocommissioning project. So all these government entities, government facilities, mainly bases, started doing retrocommission. Every year they do a retrocommissioning project. They never fixed anything. But they know that for the cost of this retrocommissioning process, they could meet their goal without actually have to meet their goal. So when I'd get one of those, I'd go in and look, and there'd be 3 other retrocommissioning reports on their desk. Say, what is this? Well, we did one last year and the year before and the year before that. It makes no sense at all, but that's what happened. That's our U.S. government. Best suited customers for RCx, building owners who have multiple buildings. And the reason for that is this is a process that takes some work to get through. It's difficult for a provider like me to actually sell the service because it takes time. It might take a couple of years to sell a person on how this will work, and so you need to have a guy that has lots of buildings. You want to sell this person retrocommission, but you want to sell it to him so you can do many buildings, not just one, because the sales process is way too laborious. And also for the owner has to contribute in these systems. A lot of them participate, some to a bigger degree than others. And so it's a training process for them. So we get college and universities who always have lots of buildings, school districts, municipalities, manufacturing facilities, hospital campuses, owners who want to be part of the process. So if you have an owner that really gets involved in the retrocommissioning process, then that's a good guy, because you will train him and he will start doing this himself, or he has lots of people trained to help you, and we'll talk about that and how I've done that in the past. So here's the stages. First stage is contract negotiation, acquisition. You have to actually get a customer to agree to what you want to do. Planning the project, you got to pre-plan the project. You got to document procurement. And this is a little bit different because on a new building, it's not a problem because you got all this stuff right in front of you. But on an existing building, it is somewhat of a problem. Now, it's a little easier these days because everything is digital. But I've seen buildings that were built 30 years ago, no digital documents. And you ask, where are the drawings? And the guy says that they're laying over on the floor in the corner of the central plant. Now, I literally mean that's happened. And you go through and sort these and try to find drawings that are even. Now, that doesn't work very well because they may not be the best drawings, but you need to have document procurement. There's a lot of documents you need to procure, and we'll go through what those are. You need to review and do a design analysis on these documents, and you need to get to see what did they actually buy the right equipment? Is the right size? You got to look at all the submittals. You got to look at all that stuff. You do the system design review. It doesn't have to be a real deep design review, but you're trying to find the problems on paper before you actually go to the field to look for them. You're going to do an level 1 energy to water audit, and for that you need the power bills and the water bills. You're going to have a kickoff meeting, which is really important, and we talk about that because that lets everybody know what you're doing. System assessment of envelope and MEP systems. So you're going to go through and assess the systems. You're going to occupy an operator interviews. You're going to talk to people. Now, when we first I was on a committee for ASHRAE to do the performance measurement protocols, which is basically the high technical activity, how you actually determine performance of a building, which sounds like it'd be simple, but it turns out it's not. And we worked for a couple of years on this standard and our special publication, actually. And we had on our committee a guy from Jones, Lang, LaSalle, and we had another guy from CBR, and we had someone else from another bit. And all these guys were huge property owners in New York City. So when we got the draft done, we said, we want you guys to take this and test it out in your facilities. And we were so excited about it. And all three of them said, I don't think so. Why? I said, well, we're not going to talk to our tenants. And I said, what? No, we're not going to ask them if they're not happy. We can't do that. And I realized they're scared of their tenants, which was really, for these huge property managers, I couldn't believe they're afraid to talk to their tenants. We'll go through how you do that. So you perform quick fixes. You take care of deferred maintenance and identification corrections. Deferred maintenance you cannot leave in the building because it definitely will cover performance issues. Initial issue discovery, issue analysis, issue root cause of each issue, and we'll be telling you how you do all this stuff. System testing. Create the facility operating guide. You will actually create a guide for the operators. This is exactly how you need to operate and maintain this building. Now that sounds like a really huge task, but it turns out it's actually not. You can do one in a couple of days, which the operators, they have a lot of O&M manuals, which might be 5 manuals, 4 inches thick, but it's very hard to figure out what's going on out of them. But you can, and you can put together a basic operating and maintenance schedule for what they need to do. Operator instruction and training if it's needed. If the operators need a little support, you can help them do that at the retro commissioning report. Then you need to perform the approved corrections, commission the corrective actions, and this is where the owner decides if he wants to spend money to fix the major portions of his building, and those need to be commissioned. Performance verification, which is PV, continued performance tracking. So you need to set this system up for an owner if he doesn't have one already. What happens if you build a new building and you get it working and you don't do a CPT, a tracking system, it will degrade over time. This system will actually improve performance over time and keep the persistence of the building good. And this can be a real cheap manual system. It doesn't need to be a big FDD system, but it can be. But normally we just use a manual tracking system, which is easy to do and actually works. Main thing to remember is that RCx is not a linear process. Now we teach it as a linear process. We don't know how else to do that. But it can be iterative in nature. You may find something during analysis or testing that requires you to go back and do more testing or research on a discovered issue to truly determine its root cause. This is really, really important. It's not that hard to do, but if you have your mindset like this, then you'll get there. So this is that CPT system. I put it here because we talk about it in the others, but I thought it'd be best to put it here. A continuous performance tracking system to verify performance over time. It's actually a Cx-8 training session because we actually also recommend this for new building commissioning, and this details it in action detail of Cx-8. You want to see that, you go to that one. But when degrading performance issues are discovered, use an RCx approach to isolate and correct all issues found. And what you do is you do have a measurement plan. You collect the data from your systems. You analyze the data. You normalize the data. There's certain normalizations. And you look for usage baselines if you're using that. And then you compare results to past results. And then you report the results to everybody. Then you make changes that you discovered over here. You make changes. And you verify to implement the changes, then it starts over. And this happens every month. And we use the retro commissioning process right here to figure out what's going on. And we correct it here, and we make this process. So that's basically the CPT process. It's not a complicated one. And if you go to Cx-8, you'll get all the details on it. Well, that's it. Pretty much all for the overview of retro commissioning. And the other videos we have will go through exactly how to perform all those issues in the field. So thanks for being here. Thanks for watching the video. I really appreciate it. I hope you enjoy the rest of them. I hope you can actually put these to use and make some money with retro commissioning. Anyway, thanks a lot. I appreciate it. I'll catch you on the next one.